Somewhere over the Everglades right now, a helicopter is flying low with a cargo hold full of dead mice. Each one has been stuffed with a common painkiller you probably have in your bathroom cabinet, and in the next few seconds, they're going to be dropped straight into the jungle canopy on purpose. This is not a prank. This is not a horror movie. This is a real government-funded operation happening in Florida right now, and the reason behind it is stranger than anything you could make up. Florida is losing a war it did not even know it was fighting for decades. An invasive predator has been quietly swallowing the state's wildlife whole, and the only weapon scientists have found that might actually work is millions of poisoned mice raining down from the sky. But here is the twist nobody saw coming. The plan designed to save the Everglades might end up killing the very animals it was supposed to protect. Stick around, because what happened next shocked even the scientists who built this thing. To understand why anyone would drop mice from helicopters, you have to go back to the beginning of this crisis. The Burmese python is not native to Florida. It never was. These snakes originally come from Southeast Asia, where they can grow to enormous sizes in dense, swampy jungle terrain that looks almost identical to the Everglades. Decades ago, exotic pet dealers realized these snakes were fascinating, cheap to import, and easy to sell to reptile enthusiasts across the United States. People bought them as babies when they were small, manageable, and almost cute. But Burmese pythons do not stay small. They can grow past 16 feet long and weigh well over 200 pounds. Owners quickly realized they had a problem no monostinis apartment or backyard enclosure could handle. Instead of surrendering these snakes to shelters or professionals, many owners simply let them go. They drove out to the edge of the Everglades and released their pythons into the wild, assuming nature would take care of the rest. What they did not realize is that they were unleashing an apex predator into one of the most biologically rich wetlands on the planet. The Everglades offered everything a Burmese python could ever want. Warm temperatures year-round, endless water, dense vegetation for cover, and most importantly, an abundant, completely unprepared supply of prey that had never evolved any defense against a predator like this. Burmese pythons breed at an alarming rate. A single female can lay up to 100 eggs in a single clutch, with virtually no natural predators in Florida, and with plenty of food, that population exploded. Scientists estimate that tens of thousands, possibly even hundreds of thousands of pythons now live in South Florida's wetlands. Nobody has an exact number because these snakes are almost impossible to see. Their camouflage is so effective that even trained biologists using dogs and thermal cameras struggle to detect them in dense grass. The damage they have caused is staggering. Studies conducted in areas with heavy python populations found declines of over 90% in raccoons, opossums, and bobcats. Rabbits and foxes have nearly vanished completely from parts of the park. Ground nesting birds are disappearing. Even alligators, the previous top predator of the Everglades, have been found locked in death battles with pythons. And it is not always the alligator that wins. This is not a minor disruption. This is a full ecological collapse happening in slow motion, right in the middle of a national park. For years, the state tried the obvious solution. Send people out to physically hunt and remove the snakes. Florida even created python hunting competitions, offering cash prizes to hunters who could bring in the most snakes or the longest snake. Thousands of pythons have been removed this way. But here's the brutal truth. Removing a few thousand snakes barely makes a dent when the estimated population is in the tens of thousands and growing every single breeding season. Pythons are ambush predators. They lie motionless for hours, blending perfectly into leaf litter and mangrove roots. A hunter can walk within a few feet of a python and never know it is there. Scientists needed something smarter, something that could reach snakes hunters could never find, hiding deep in areas that are physically impossible for humans to search. And that is when researchers turned to a strategy that had already been tested thousands of miles away on a completely different island, against a completely different snake. Back in the 1940s, the brown tree snake accidentally hitched a ride to the island of Guam, likely hidden in military cargo shipments after World War II. With no natural predators and an island full of naive prey, the brown tree snake population exploded almost exactly the way Burmese pythons have in Florida. Within a few decades, the brown tree snake wiped out almost every native forest bird species on Guam. Some of those bird species do not exist anywhere else on Earth anymore. They are simply gone, driven to extinction by an invasive snake nobody planned for. Guam's snake problem got so severe that the snakes started climbing into power stations and causing island-wide blackouts by shorting out electrical equipment. The economic damage ran into the millions of dollars every single year. The United States Department of Agriculture stepped in and began testing every possible method to control the population. Traps worked, but only in small areas. The snakes were too widespread, too well hidden, and too numerous for physical removal to ever work at scale. Then researchers made a discovery that changed everything. Acetaminophen, the active ingredient in Tylenol, is completely safe for humans in the correct dosage. But for snakes, it is a completely different story. Acetaminophen interferes with a snake's hemoglobin, disrupting its ability to carry oxygen through the bloodstream. The snake essentially suffocates from the inside, slipping into a coma before dying. For humans, dogs, and most mammals, the tiny dose used in these baits is far too small to cause any harm. But for a snake's unique biology, it is lethal almost every time. Researchers began inserting small acetaminophen tablets into dead neonatal mice, the kind of prey a snake would naturally hunt and eat without hesitation. They discovered something clever. If you simply drop a dead mouse on the ground, it often gets eaten by ants, crabs, or scavenging birds before a snake ever finds it. So scientists attached each mouse to a small cardboard device with a long paper streamer, almost like a tiny parachute. When dropped from a helicopter, the streamer catches on tree branches, keeping the mouse suspended in the canopy instead of falling to the forest floor. This targets the exact vertical zone where brown tree snakes hunt, keeping the bait away from ground-dwelling scavengers that might eat it first and waste the dose. The results on Guam were remarkable. Field trials showed the acetaminophen baits were readily consumed by brown tree snakes and proved acutely toxic, causing significant mortality in treated areas. An automated aerial delivery system was eventually developed, allowing researchers to blanket large sections of forest with these baits in a single flight. It became one of the most effective tools ever developed against an invasive snake species anywhere in the world. So when Florida officials looked at their own python crisis, spiraling out of control with no end in sight, they started asking an obvious question. If poisoned mice worked against snakes in Guam, could the same idea work against Burmese pythons in the Everglades? On paper, the science lines up perfectly. Pythons, like brown tree snakes, are reptiles vulnerable to the same acetaminophen toxicity, and juvenile pythons, the ones most responsible for driving future population growth, actually hunt small rodents just like their Guam counterparts. Adult pythons have moved on to deer, raccoons, and even alligators, so a mouse means nothing to them. But young pythons, before they get large enough to take down bigger prey, rely heavily on rodents to survive and grow. This is the real strategic genius behind the plan. Instead of trying to kill fully grown pythons that are already established, breeding, and difficult to detect, researchers want to intercept the next generation before it ever gets the chance to reproduce. Juvenile. Pythons also climb far more than adults do, spending significant time in shrubs and low canopy while hunting and avoiding larger predators. That means the same canopy-targeting streamer trick used in Guam could theoretically place bait in exactly the zones where young, vulnerable pythons are actively foraging. It sounds like the perfect solution. Cheap, scalable, and biologically precise. But here is where the story takes a much darker turn, and where scientists themselves admit they are walking a genuine tightrope. Guam's forest, by the time this baiting program began, was already what ecologists grimly call a ghost forest. Most native birds were already extinct because of the brown tree snake itself. There was almost nothing left for the acetaminophen baits to accidentally harm, because the snake had already wiped out most of the vulnerable species years earlier. The Everglades is nothing like that. It is one of the most biodiverse wetland ecosystems left on the planet, still teeming with native species that never had the chance to go extinct. And that abundance is exactly what makes this plan so risky. If the mice are eaten by the wrong animal, the consequences could be catastrophic. Florida is home to raptors like bald eagles and hawks that regularly scavenge dead animals from the forest floor or canopy. A single dose of acetaminophen might not kill a full-grown adult raptor outright, but toxins like this can accumulate in the body over repeated exposure. Worse, adult birds sometimes feed scavenged food directly to their chicks in the nest. Scientists fear a slow, invisible disaster where entire generations of raptor nestlings quietly fail to survive, without anyone realizing why, until populations have already crashed. This is sometimes referred to by ecologists as a silent spring scenario, a nod to the famous warning about pesticides decimating bird populations decades ago. Then there is an even more painful irony buried inside this plan. The eastern indigo snake is a native, federally protected species in Florida, and it happens to be one of the few animals that actually preys on young Burmese pythons. In other words, nature already gave the Everglades a built-in python fighter. But indigo snakes also eat mice. If a mass baiting campaign accidentally poisons indigo snakes along with the pythons, Florida could end up wiping out its own best natural defense in the process of trying to build an artificial one. And then there's the animal that keeps every wildlife biologist up at night when this plan comes up, the Florida panther. With an estimated population of only somewhere between 120 and 230 individuals left in the entire world, the Florida panther is one of the most endangered mammals in North America. Every single animal matters for the survival of the species. Felines, unlike most mammals, process acetaminophen extremely poorly. Their livers lack a key enzyme most other mammals use to safely break the drug down. A dose that would barely register in a raccoon or a dog can be fatal to a cat. If a Florida panther were to scavenge even one poisoned mouse carcass or eat a python that had recently ingested one, it could be enough to kill one of the rarest big cats on Earth. This is the impossible position wildlife officials found themselves standing in. Do nothing, the pythons continue devouring the Everglades mammals and birds unchecked, eventually threatening the same panthers and indigo snakes conservationists are desperately trying to protect. Deploy the poison, and there is a real risk of accidentally killing those same protected species in the process. It is a genuine ecological catch-22, and researchers like field biologist Marcus Reyes, who has been on the front lines of the earliest test drops, describe it as testing far more than a pesticide. They are essentially testing the ethical limits of intervention itself. Because of these enormous risks, Florida's mouse drop program has not launched as some blind, statewide operation. Researchers have moved with extreme caution, running small, tightly controlled trial deployments in limited test zones first. Before mice are ever loaded onto a helicopter, biologists survey the target area, checking for panther activity, indigo snake habitat, and nearby raptor nests. Camera traps and radio transmitters track exactly which animals interact with the bait and how quickly it disappears from the canopy, giving scientists hard data instead of guesswork. So what actually happened when the first real trial drops went ahead? The early results have surprised almost everyone involved, though maybe not in the way you would expect from dramatic headlines. In the specific test corridors where mice were dropped, researchers documented juvenile pythons consuming the treated bait and dying from acetaminophen toxicity, confirming the biological premise scientists had been banking on since the Guam data first suggested it could work. That alone was a massive validation, proving a strategy built for one invasive reptile thousands of miles away could transfer to a completely different species and ecosystem. But the more fascinating discovery came from the non-target monitoring data. In the carefully chosen initial test zones, researchers found dramatically lower rates of accidental bait consumption by mammals and birds than some of the worst-case models had predicted. The streamer and canopy placement system, originally engineered for Guam's forest, appears to be doing exactly what it was designed to do here too, keeping bait away from ground-foraging scavengers long enough for arboreal juvenile pythons to find it first. That does not mean the risk to panthers, indigo snakes, and raptors has vanished. Scientists are extremely clear that these early numbers come from small, heavily monitored test areas, not a wide-scale rollout across the entire Everglades ecosystem. Nobody involved in this research is declaring victory yet. What nobody fully expected, though, was just how much attention this story would generate outside the world of wildlife biology once it reached the public. A program built quietly by researchers suddenly became a viral sensation, with people across the internet reacting with fascination and disbelief that something this strange was actually real. The image of helicopters dropping thousands of drug-laced mice into a swamp sounds like science fiction, yet it represents one of the most scientifically rigorous invasive species. Control efforts currently underway anywhere in the United States. It forces a much bigger, uncomfortable question that goes far beyond snakes and mice. How much are we willing to risk manipulating one part of an ecosystem in order to save another part of that same ecosystem? There is no clean, easy answer here. Every option on the table carries a cost. Doing nothing allows an unstoppable invasive predator to keep consuming its way through one of America's last great wetlands. Acting means accepting a level of risk to species we are simultaneously trying to protect, hoping the science and the precision engineering hold up outside the controlled conditions of a small test trial. Florida's wildlife agencies have stated they intend to expand monitoring significantly before any wider deployment decision is made, watching closely for any sign of harm to panthers, indigo snakes, or nesting raptors before scaling this program up any further across the Everglades. For now, the Everglades sits in this strange, tense middle ground. Millions of mice may eventually fall from the sky over one of the most fragile ecosystems on the planet, aimed at saving it from a predator that should have never been there in the first place. Whether this becomes one of the great conservation success stories of our generation, or a cautionary tale about the unintended consequences of human intervention, is still being written in real time, one carefully monitored test drop at a time. What do you think? Would you support a program like this if you lived near the Everglades, knowing the risks involved? Drop your thoughts down in the comments, because this debate is only just getting started. And if stories like this about the strange hidden side of science and nature fascinate you the way they fascinate us, make sure to hit that like button and subscribe to the channel so you never miss what we uncover next. The story of Florida's pythons is really a story about consequences nobody planned for decades ago. A handful of pet owners making individual, seemingly harmless decisions to release snakes they could no longer care for eventually snowballed into one of the most severe invasive species crises in modern American ecological history. Now, the solution being tested to fix that crisis carries its own set of unintended consequences that scientists are racing to understand before it is too late. It is a reminder that ecosystems are deeply interconnected webs, where pulling on one thread, even with the best intentions, can send ripples through everything else attached to it. Researchers point out that this situation highlights something often overlooked in conversations about invasive species. Prevention is almost always cheaper and safer than control after the fact. Once an invasive predator establishes itself in an environment as vast as the Everglades, there is no simple, risk-free way to remove it. Every available tool, from hunting competitions to poisoned bait drops, comes with trade-offs. Researchers must weigh against the alternative of doing nothing at all. What makes the mouse drop program compelling as a case study is how it represents a genuine collaboration between different fields of science working toward a single goal. Toxicologists had to determine the exact dosage that would reliably kill a python without requiring an impractically large bait. Engineers had to design a delivery mechanism, that cardboard and paper streamer system, capable of surviving a helicopter drop and snagging reliably in dense canopy instead of crashing to the forest floor. Wildlife biologists had to map sensitive habitats for panthers, indigo snakes, and nesting birds to minimize overlap with treated zones. And behavioral ecologists had to study exactly how juvenile pythons move through the canopy to make sure the bait placement matched their real-world behavior in Florida, rather than simply copying Guam's approach without adaptation. That level of interdisciplinary precision is part of why researchers remain cautiously optimistic despite the very real dangers involved. This is not a blunt instrument. It is closer to a scalpel, designed with an enormous amount of restraint and monitoring built directly into every stage of testing. Whether that precision proves to be enough once the program eventually scales beyond small trial zones remains the biggest open question hanging over the entire Everglades restoration effort right now, and it is one that scientists, conservationists, and Florida residents alike will be watching unfold for years to come. There's also a financial side to this story that rarely gets mentioned outside of research papers. Python removal through human hunters, while emotionally satisfying and great for headlines, is extremely expensive per snake once you calculate the cost of manpower, equipment, and hours spent searching dense wetland terrain for animals that are almost invisible by design. Aerial bait drops, once developed and tested, can cover enormous areas of inaccessible swamp in a single flight for a fraction of that cost. If the program proves safe enough for wider use, it could completely reshape the economics of invasive species control across the entire state. Florida has tried other creative solutions before this one, with mixed results. Trained detector dogs have been used to sniff out python nests hidden in dense brush. Scientists have even implanted radio transmitters into captured male pythons, nicknamed scout snakes, and released the M back into the wild during breeding season, specifically because males will instinctively lead researchers straight to breeding females, who can then be removed along with their eggs. Each of these methods has added a small piece to the puzzle, but none has slowed the population's overall growth in any lasting way. The mouse drop program represents the first strategy with real theoretical potential to work at the scale this crisis demands. Public reaction to this story has also revealed something interesting about how people relate to conservation efforts. Many viewers online initially recoiled at the idea of deliberately poisoning any animal, even an invasive one, only to change their perspective once they learned about the sheer scale of destruction pythons have caused to native wildlife across South Florida. Others raised valid ethical questions about whether humans, having caused this crisis through the pet trade, now have a responsibility to fix it using whatever tools are available, even risky ones. Ultimately, this saga captures something bigger than snakes, mice, or even the Everglades itself. It captures the difficult reality of managing damage humans have already done to the natural world, using tools that are themselves imperfect. There is rarely a clean solution once an ecosystem has been thrown this far out of balance. What Florida is attempting right now is a genuine high-stakes experiment in whether careful science can undo, or at least contain, a mistake that started decades ago with pet owners who never imagined the consequences of letting their snakes go free in a Florida backyard.